Hey everyone, welcome back to One Dimensional Kinematics and the Adventures of Jim and Cindy. This time we will be talking about speed and velocity and doing example problems with that.
Okay, so now we are on speed and velocity, example number 5. Cindy sees an ice cream truck and charges towards it to the right. She runs 60 meters in 8.2 seconds. What is her average velocity in meters per second and miles per hour? Alright, so again, you want to just kind of draw out the problem. What we see is she's going to be running towards this ice cream truck, getting her favorite ice cream, which is 60 meters away, and it's going to be taking her 8.2 seconds. So what we're looking for is the average velocity. First, let's do it in meters per second because that's easier. And we know velocity is equal to the displacement divided by the time. We're looking for velocity. We know that displacement is going to be 60 meters to the right, so we could just put positive 60, or I'm just going to put 60 meters. And the time it takes is 8.2 seconds. We put this in our calculators, and what we get is goes 7.32 meters per second. So you can put this as your answer, or since it's asking for velocity, you can also put 7.32 meters per second right, giving the direction. You don't have to put right because since it's a positive number, it implies that it's going to the right. However, if you want to be more specific, you can do that. Now, a little bit more tricky is we have to find the miles per hour, which means we have to do dimensional analysis. So, when we have 7.32 meters per second, we need to get rid of meters and change it to miles, and we need to get rid of seconds and change to hours. So, what we're going to do is, in order to get rid of this meters, we have to multiply by something of meters. And what we want instead is miles. And we can't just multiply a random thing, we have to multiply by 1. So we know that 1 mile is equal to 1,609 meters. This way we're not doing anything illegal mathematically. And what we can do is we can get rid of the meter, and we get what we want, which is the mile. Same thing over here. Now what we want to get rid of is we want to get rid of seconds by having something in the numerator. And instead of seconds, we want an hour. If you wanted to go to minutes first, you could do that. And we should know 1 hour is equal to 3,600 seconds. 60 minutes, and then one minute is 60. 60 minutes is 1 hour, so 60 times 60 is 3,600. This way we've gotten rid of the seconds, and we got what we want, which is the hour. We multiply this out, and we get 16.38 miles an hour. And or you could put 16.38 miles an hour. Since we're looking for a velocity, we can just say it to the right. Again, if it's positive, it implies that it's going to the right, or up, or east, or something like that. Important thing to know here is the miles per hour is going to be around 2 or 3 times more than the meters per second. So this is 7.32, so it should be around 2 or 3 times more. Okay, and that's kind of how you can roughly check. Part B says, what is her average speed in meters per second and miles per hour? And we know speed is equal to distance over time. And since the distance and the displacement is the same in this case, we know that it's going to have the same answer. Except we don't have to put right or anything like that because speed doesn't have direction. So we can put 7.32 meters per second. And then we can put 16.38 miles an hour. And since she only moved in a straight line, again, the distance and displacement are the same, so they have the same answer in magnitude. But when she got to the ice cream truck, what did she get? She got a strawberry shake. She got a strawberry shortcake ice cream cone. Those are the best. All right. Next question, number 6. Jim sees a spider and lets out a loud scream. Then he starts running away as fast as he can to the left. He travels 20 meters in 10.2 seconds. What is his average velocity in meters per second and miles per hour? Okay, so similar problem, but things are a little bit different. So let's see. He goes to the left 20 meters. It's going to take him 10.2 seconds. You want to kind of draw out everything first. Okay, so again, velocity is equal to the displacement divided by the time. We're looking for what his velocity is. And his displacement, he starts over here, but he goes to the left 20 meters. So his displacement is going to be negative 20 because he starts here, but he goes to the left 20 meters. How far he is from where he started. So negative 20 meters is his displacement, and it took him 10.2 seconds. And then what we get is his velocity is equal to negative 1.96 meters per second. Or, if you want to put the direction, because the negative implies the direction, if you want to put the direction, you can put 1.96 meters per second left. Okay, so any of these two are acceptable for the velocity. But now what we want is miles per hour. Again, we want to do the same thing with dimensional analysis. So 1.96 meters, I'm going to put per second. Let me just change this, meters per second. And again, we want to get rid of the meters and put into miles. And we know 1 mile is 1,609 meters. This way we could get rid of this meter, and we have what we want, our mile. And we want to get rid of the second, and we want to change it to hours. We know 1 hour is equal to 3,600 seconds. The seconds cancel out, and we get what we want, our hour. Do some calculations, and we get, this is going to be negative. This is going to be equal to negative 4.39 miles an hour. Or, again, we could put 4.39 miles an hour left. Okay. So, what is his average speed in meters per second and miles per hour? Again, since the distance traveled is the same thing, we have the same answer, except distance has no negative or positive, it just has, how far you are. So instead of doing negative 20 meters over 10.2 seconds, the speed is equal to the distance over time, which is just 20 meters divided by 10.2 seconds. Which gives us 1.96 meters per second, or if we convert it, 4.39 miles an hour. But the real question, what happened to Jim and the spider? So actually, Jim does get bitten by the spider, but he does not turn into Spider-Man. Very sad life for Jim. Alright. Example number 7. Jim and Harry are walking to the bus stop, which is 0.5 miles to the left of Jim's house. It takes them 20 minutes to arrive to the bus stop. As soon as they get to the bus stop, Jim realizes he forgot his lunch and runs back home. He then rushes back, which takes him another 12 minutes. What was Jim's average velocity in meters per second for the entire trip? Okay, so we want to kind of draw all this out because there's a lot going on. So I'm going to draw this out to the left here. This is Jim's house, and we'll put this as the bus stop here. It is 0.5 miles from the house. So first, in the first scenario, Jim walks to the bus stop. So I'm just going to draw it like this. Jim walks to the bus stop, and it takes him 20 minutes. However, when he gets to the bus stop, he has to go back. So he has to go back. I'm going to do this in red. And then it takes him 10 minutes because he rushes back. I'm going to call it maybe T2. I'm going to call this 10 minutes. And then once he gets his lunch again, what he does is he goes back. I'm going to call this T3, and it takes him 12 minutes. Okay, so going a lot of back and forth here. So question A is asking, what was Jim's average velocity in meters per second for the entire trip? So there's a few things going on here. First, we have things in miles and minutes, but we want it in meters per second. So let's just get the answers in the units that we have. We know that velocity is equal to the displacement divided by the time. What's important to know with this problem is the displacement. He starts here, zigzags, and ends up over here. So his starting position is at the house, and his ending position is at the bus stop over here, which is 0.5 miles to the left. So that means his displacement is going to be negative 0.5 miles. And the time that it takes to get to this point over here is going to be 20, another 10, and 12. So it's going to be a total of 42 minutes to get to that bus stop. Okay, so let's find out what this unit is. So we get negative 0.5 divided by 42 minutes. So we get negative 0.0119 mile per minute. But we want to change this into meters per second because that's what it asks for. So we have to get rid of miles and put it into meters. We know 1 mile is equal to 1609 meters. And we have to get rid of minute and put it into seconds. And we know 1 minute is equal to 60 seconds. So let's put this all out. And what we get is his average velocity is negative 0.319 meters per second. Okay. Part B says, what was Jim's average speed in meters per second for the entire trip? And let me do this in another color. What we know is speed is equal to distance over time. And this is a little bit different because the distance that Jim walked wasn't just 0.5 miles. He went 0.5 miles, 0.5 miles, and 0.5 miles. So his distance was 1.5 miles all over 42 minutes. And what we get for this is 1.5 divided by 42. 0.0357 miles over minutes. But we need to convert this to meters per second. So let's just put this over here. 0.0357 miles over minute. Let's get rid of the mile. Change it into meters. 1609. Let's get rid of the minute and change it into seconds. And then what we get is 0.96 meters per second. But the real question is, did he make his bus? Jim actually misses his bus, but Harry is still waiting at the bus stop so that they can walk to school together. What a good friend Harry is. Alright, next problem here. So, Cindy is running a 5K, which is 5,000 meters, a loop for her first cross-country meet. Jim wants to make sure he's at the finish line when she finishes, but he also wants to get a hot dog. Oh God. Cindy usually runs with a speed of 4.3 meters per second. About how long does Jim have to get his hot dog? Alright, again, we want to draw out this problem. So, Cindy is going to be running in a loop. Running in a loop like this, and the distance, let's just call this the start and finish line. The distance she's going to be covering is equal to 5,000 meters. We know she's going to be running this with a speed of 4.3 meters per second. And we want to know about how long does Jim have to get his hot dog, meaning how long is it going to take her to finish this race. So we're looking for the time. Okay, so now that we have our knowns and our unknown, we're going to be looking for what this time is. So we know speed is equal to distance over time. That being said, we know she's running it with the speed of 4.3 meters per second. She's running a distance of 5,000 meters. And we want to know how long is this going to take. So we have to do a little bit of algebra here. We're going to put this time onto this side. And then we're going to put the 4.3 onto the other side. So time is equal to 5,000 meters divided by 4.3 meters per second. And what we get for the time is equal to 1,162.8 seconds. So this is the answer. But if you wanted to convert it to minutes or anything like that, it's also equal to 19.38 minutes. Okay, we see the meters cancel out, and what we get for the time is a unit in seconds. Next question is, what is Cindy's average velocity when she finishes the race? So different from distance over time, velocity is equal to the displacement divided by time. But if she goes in a circle like this, she starts and ends at the exact same spot. So her displacement is equal to 0. And what that means is her average velocity is 0 meters per second. But the real question is, was Jim able to make it in time with the hot dog? Cindy is actually happy to see Jim at the finish line cheering her on. However, she gets a little annoyed because he is eating his hot dog instead of getting her any water. Oh man, Jim can't get a break. Alright, conceptual example number 2. If someone is moving at a constant speed of 10 meters per second, this means that the person A increases her speed by 10 meters every second, B decreases her speed by 10 meters every second, C moves with the acceleration of 10 meters per second every second, D moves 10 meters every second. So let's just kind of boil this out. 10 meters per second. So let's just write it out what this means. 10 meters per second. What this means is every second this person is going to be moving 10 meters. So in 1 second moving 10 meters, in 2 seconds 20 meters, 3 seconds 30 meters. Same thing when you hear something like 50 miles an hour. Every hour the car travels 50 meters. Okay? So in this case 10 meters per second moves 10 meters every second. That's what the speed means. So how far it moves every second. Okay, back to Jim. Jim noticed how much Cindy liked him being at the cross-country meet. He decides to train so that he can join the team. He sprints 100 meters in 13.2 seconds. Then he takes 50 seconds to walk back to the start line. If his sprint direction is positive, what is the average sprint velocity? Okay, so let's see. Jim is here. Oh yeah, Jim. Yeah. And he's running. He's running the positive direction, so we'll just kind of put that in the right. So 100 meters, and it takes him 13.2 seconds. Okay, so we're looking for his sprint velocity. Velocity is equal to the displacement divided by time. And then we see the displacement is he moves 100 meters in the positive direction. So 100 meters, and it takes him 13.2 seconds. This means that his velocity is going to be equal to 7.58 meters per second. Now, so what happens after that is, so he does this and now he walks backwards. So now he walks backwards and he goes back 100 meters, but it takes him 50 seconds. So we'll want to find the average walking velocity. So it's taking a lot longer, so it should be less than 7.58 meters per second. We know velocity, again, is equal to displacement divided by time. However, we know even though he moves again 100 meters, he's going left this time. So that means he starts here, moves to the left 100 meters. So this is going to be negative 100 meters because he moves to the left 100 meters, and it takes him a time of 50 seconds, which is going to be equal to negative 2 meters per second. Last part is the average velocity for the complete trip. So remember, he runs this way, goes back this way, so he starts and ends at the same spot. What that means is his displacement is equal to 0. And if his displacement is 0, that means his velocity is also 0. So that means it's going to be 0 meters per second.